So this is our robotic clip install machine, and the reason we developed this was to make an easier, simpler solution for manufacturers in automotive, particularly industrial and appliances. And we really focused on flexible integration with this equipment. So it's designed with a C-shaped frame, so an operator or a robot can load parts, but you can also remove the front legs, and a pallet can pass underneath, or a dial table. So it's really designed to work in any scenario without custom modifications. An integrator or an end user can purchase the equipment, bolt it down over top of one of their conveyance methods, and have it up and running in a matter of hours because of our included interface that we've developed. So the proprietary portion here, the head and tool, is able to hold 25 clips in the head and then apply them into the part. I'll do a quick little show here. Our clip-to-clip cycle time is approximately 2 seconds, and it refills the head in just about 1 second. So it's extremely quick, and we're designing it for maximum throughput and reliability. I'm going to keep running it here while I talk, because it's going to go over and pick up from the feeder. This part here has 4 clips on it, so it's only refilling the head every 3 or 4 cycles. Up top we have the feeders, and we have, in this case, 4 of them. The reason we did that is to give reliability and redundancy. If one of the feeders is struggling or out of clips, it'll automatically switch to the other feeder to continue your production. So basically, you're not going to have any downtime with this system. If you need to perform maintenance on the feeders, you have multiple, again, so you can simply remove the feeder from the system, work on it on a bench where it's ergonomic, and you're not impacting production because you have other feeders that are able to run during that. So this is running at about 70% speed right now. We can increase the speed. And there is a complete refill cycle, 25 new clips in the magazine for the next cycle. I can clear this part here and rerun it just to show you can be back up and running in a split second. So in the background, while this is running, that feeder that it took the clips from is refilling. And the tool will go to whatever feeder is ready when it needs clips. So it picks and chooses either the closest or the most ready feeder. And so each feeder can hold approximately 4,000 clips. Oftentimes, 2 feeders will get you a whole day of production without having to refill. And so here it's going for a refill, and there it's refilled 25 clips in just that amount of time. All of that time is buried cycle time while the part is conveying into the system. So again, there's no downtime with this system. It's designed to run 24/7 in a factory if needed. I'll run it one more time here. Our working window on this machine is 1,000 millimeters wide, 750 millimeters deep, and 300 millimeters tall. We do have 2 other sizes of equipment, so we can go larger, and another machine is half the size. So we're really trying to focus on it being as compact as possible to save square footage in your plant. We have customers that are interested in integrating it on the outfeed of mold lines in those tight areas, so the small one is really ideal for that. Our interface up here, we've really developed to make it as user-friendly as possible. You can teach points in the system in a matter of minutes. You don't need a programming background, and you don't need any robot training. So anyone, maintenance or manufacturing engineers, can easily set this system up and maintain it with no special training. If we walk around here to the back, I will show you the feed system. So we've developed these feeders, like I said previously, to be modular, and I'll just turn it on here. You'll get a bit of a demo. So we singulate the clips from their bulk format here, and we store 25 clips in a vertical magazine. The head then comes over to get those clips, and it's just going to fill up here. It takes about 10 to 15 seconds to load 25 clips before it dispenses them into the head. So now it's doing a dispense demonstration, and that's it. In this whole system, we've developed an anti-jam technology. So if there is a jam detected inside the track, the feeder will simply open up and dump all those clips and automatically continue. So you don't have any of the challenges with traditional systems of having to shut down the equipment and remove jams manually. So here's the demonstration. It's going to open up, dump all those clips, and just restart. That same technology is also in the head. So anywhere that the clip is touching the equipment, it's able to recover from a potential jam if it did occur. Again, the whole design was to focus on flexible integration, but also reliability and uptime. This unit has its own control system, so it's shipped fully turnkey. You literally plug it into a 120 volt outlet. It runs about 5 amps, and then you're up and running, like I said, in a matter of hours.